So in the first example that I gave you in the notes, we had a hypothesis test where our claim was that the mean was less than 8.5 hours. And this led us to a left-tailed hypothesis test, and thus we had a negative critical value. So in the other two examples, we're going to look at the other two cases, a two-tailed test and then a right-tailed test. So with the hypothesis test that we're looking at here, if I start with the claim, which is what I always do, a study says that the mean, again, this is a claim about mu, the mean time to recoup the cost of bariatric surgery is 3 years. So what I want to note here is that my claim, in this case, it's not a less than or a greater than. My claim here says the mean is or is equal to 3 years. So when I look at the opposite of that claim, I'm going to have a statement of mu is not equal to 3. And then based on what we know already, when I set up my null and my alternative hypothesis, the statement with equality always goes to the null. Inequality goes to the alternative. All right, and we talked about this in the previous example too, that when you set up your null and alternative hypothesis, you want to make a note of which one is your claim, because sometimes it will end up in the null like here, sometimes it will end up in the alternative like the first example, and that makes a difference in how you interpret that information. All right, now the next thing I'm going to do is look at the sample data, make sure that I'm using the right kind of test. So notice we're going to select 25 surgery patients. We got a sample size in here of 25. We find a mean for the sample, that's a value of x bar, to be 3.3 years. And then notice here we were given the population standard deviation. That means we know the value of sigma is 0.5. And just like with the confidence intervals, that is what you use to make a choice of whether you should use Z or T. When I see that I know the value of sigma, that tells me this is going to be done using Z, the standard normal distribution. And I can verify that if I go back and check the other conditions as well. So sigma is known. We do have a randomly selected sample. And even though my sample size is not 30 or more, I'm still okay because I am given a normally distributed population, which is what I'm seeing right here. So that lets me know that my rejection region and my critical values will come from the standard normal distribution. All right, so that's what I'm going to do next. Now, I always like to do my critical values and rejection region as step 2 and my test statistic as step 3. But just to give you a heads up, in some of the homework problems, it will reverse that order, and it will ask you for the test statistic in step 2 and the critical values in step 3. So just pay close attention to what it's actually asking you for. What we're finding here is the critical values and the rejection region. Now, to shade the rejection region, I need to look back at the initial setup, look at the alternative hypothesis, and because the alternative hypothesis contains not equal to, that lets me know this is a two-tailed test. And so I'm going to shade my rejection region, split between the left and the right tails of the curve. And that also means I'm going to have two critical values, one negative and one positive. Now, to find my critical values, I'm going to take the level of significance. That's the probability that our test makes a mistake or an error. And because this is a two-tailed test, I'm not going to use alpha. I'm going to use alpha over 2 to find the critical value. So that means the area that I'm going to use to find the critical values is going to be 0.005. So I'm going to take that to my standard normal table, and I'm going to search for an area, or as close as I can, to 0.005. Now, as you search for this area, you're going to find this is one of those special cases where you can't pick one area that's closer than the other. These are equally spaced from 0.005. And so what that means is you're going to have to average your z-scores here, negative 2.57 and negative 2.58. And that's going to give me a critical value of negative 2.575. Now again, because this is a two-tailed test, I know I'm going to have both a negative and a positive critical value. All right, and so again, just pay close attention when you're going through the homework. Make sure that you're putting these in the right spots. So what we just did here is we found the critical values and we shaded the rejection region. Now, the test statistic, which is where I'm going to go from here, the test statistic is a formula. All right, and we define that formula in our basic steps here as taking the sample mean minus the value of mu and dividing by the standard error, which is sigma, over the square root of n. And because I've laid out everything for my sample here, this is really just going to be a matter of plugging everything in. So I'm going to take my sample mean, which was 3.3. Always start with the sample mean first. And for the value of mu, what I'm going to plug in is the value that I am testing. And then I'm going to divide that by sigma, the population standard deviation, which was 0.5, over the square root of n, the sample size, which is 25. Now, you want to be careful when you evaluate this. Either make sure to use parentheses carefully, or you might evaluate it in two steps and kind of approximate that denominator. All right, so I'm going to take 3.3 minus the mean of 3, what we're testing. And notice I went ahead and hit equal because I wanted that to go ahead and evaluate. And then when I divide, I'm going to open up parentheses, and I'm going to take 0.5 over the square root of 25, close my parentheses, and then hit enter to evaluate. All right, and again, if you have trouble getting your test statistic to evaluate correctly, then what I would encourage you to do is evaluate the top part, evaluate the bottom part, make sure not to round it too short, and then just do an extra step of dividing those two things. All right, now, to make our decision, we know that we take this value and we compare it to our shaded rejection region. We want to see, is it in the shaded region or is it in the unshaded region? So we've got a positive 3 here. That's going to be over here on the right-hand side of the curve, and it is going to be past 2.575, which means it is in the shaded rejection region. So again, the way my decision rule works, if I am inside the shaded rejection region, which I am here, that tells me that I should reject the null hypothesis. And that's what we call the decision for the test. Remember, the decision is either reject the null hypothesis, or if you're in the unshaded region, then you fail to reject the null hypothesis. And so my last statement here will be to interpret that decision. And I talked about this with you a little bit in the first example as well. Anytime you reject the null hypothesis, that's what the test is trying to do. So your interpretation will start here with there is enough evidence. That's based on the decision. And then you look back at where your claim sits. Anytime the claim is in the null hypothesis, like it is here, the test will always try to reject the claim. And so in this case, rejecting the null hypothesis means there is enough evidence to reject the claim that the mean is equal to 3 years. And again, remember, if that interpretation gives you trouble, because it tends to be a little bit confusing at first, if that gives you trouble, remember I put a little flow chart for you here at the end of your notes, and so you can use that to kind of help you as well. So like in this case, my claim was in the null hypothesis. I saw that in the very beginning. My test told me to reject the null hypothesis, and so here was my interpretation. There is enough evidence to reject the claim. All right, so that gives you an example of the left-tailed test and now a two-tailed test. All right, so go and work through some of those and then come back and watch the third video, which will give you an example of a right-tailed hypothesis test.